Hey, everybody. I have a mute button. Brian has a mute button. Watch. I can at any time the button. There we go. I can see the levels jump, but I also hear it in my headphones, so I knew I was muted. Good morning, everybody. Sorry about that. I literally hit the mute button between classes and didn't notice I hit the mute button. And then I was like, is it my mixer? What's going on? And I looked over and I saw the mute button was on. That's got it. We got a lot of questions here to start. Wow, we got a bunch of people here. I love it. Jillian had the first question. Kate's got a few, and then Kylie has the next. So we're going Jillian, Kate, and Kylie right here. I'm stuck on chapter 2 quiz. I know you've gone over some questions, which could go over the ones that have getting the mean and the median for the salary of the workers. Let's go over here and look at a Stat Tool 1 question, the mean and the median for the salaries of the workers. And thank you so much for everyone being here. Remember, we do all the questions we can in the order we get them. So put your questions in the chat. We're going to do Tool 1. Then I think we're doing some more Tool 1. Kate has questions about Chapter 2 quiz. How do you tell the range IQR standard deviation would be a better measure of the spread? So when we do the range, or when we're telling the best measure of spread, we have to look at the what? So this is to Kate's questions while I get this loaded up right here. If we're trying to tell the best measure of spread, what should we look at to start? When we're trying to find the best measure of spread, visualization 2. Awesome. Oh, your Trevor, we'll take a look at that in a second here. Can you have homework due on Sunday one time just so... I think we do for some classes. We do. So Sunday.
Sunday.
There we go. I got it. How do you tell what's the best measure of center and spread? So who knows Stat Tool 1, which this applies to a bunch of other classes too. How do we know what the best measure of center and spread are? How would we figure out what the best measure, and I've almost got the assignment up here. How would we figure out what the best measure of center and spread are? I'm going to pull up the salary data set. How do you know what the best measure of center and spread are? Finding the salary data. The shape, the skew. Is the data skewed or is it normal? So if it's skewed, we want to use median and IQR respectively. If it's normal, we want to use mean and standard deviation respectively. So let's get to take a look at this first question right here with the salaries of employees. First question here for 201. Next topic. 201, salary of employees. Next topic. I've started saying that because it really helps me find when I come back and do the video review of this later and put in the timestamps. So we have right here, this one confuses a lot of people because we have here a bunch of workers at a company. And these workers, a supervisor, good to see you here, Roderick, $13.50 is their salary, $8.50 is another salary. And these have 6 stock boys and 4 drivers. So this is where the errors occur in this question, I believe. Let's go over here and go into Jump. You could do it in Excel, but I prefer to work this in Jump. We're going to go over here to a new data sheet, File, New Data Table. So we're inside of Jump right here, File, New Data Table. If you don't see the top menu bar, you might have to go to the very top on a Mac. On the Mac, it's going to be all the way up here. So I think Trevor was asking about this. Trevor, if you don't see this menu bar on a PC, it's at the top of the window, but on a Mac, it's going to be all the way up here at the very top of the screen. It'll appear when you go up there. Macs kind of hide the menu bar. So we're going to go to New Data Table, and we're just going to get a new data table like we currently have. So with this new data table, we're going to enter in the data. Now here's where people make an error. Is if you notice, there are in here 6 stock boys, and I'm entering them in an order, and there's 4 drivers. So why am I entering in 504 times? Who can explain in the chat for some 20 points? Why am I entering in 504 times? Why did I enter in 504 times? Why did I just do that? Why did I just do that? Why did I enter in 504 times? Because there's 4 of them. 20 points right there. Great job, Jillian, right there. You are right. There's 4 of them. So there's 4 of them, and there's 6 stock boys right here. So I've entered in the salaries accordingly. So we have all the salaries entered in, just how they occur. And now you notice we have to look at the mean. So let's go to Analyze Distribution. Once again, that's Analyze Distribution right there at the top of the screen for Mac users. And under Analyze Distribution, we're just going to double click the variable. That's going to put it in here, and then we're going to click OK. And we could find the mean ourselves. I'm going to stack right here, just put it in horizontal layout. So you could find the mean yourself. How would you find the mean if you wanted to for all this data right here? How could we find the mean for all this data if we had to on a test? I'll start doing it, and I want you to explain it in the chat while Brian sits here and does the laborious process of finding the mean by doing what we could have to do. This is possible on the test. Good. My eyes are blurring on that. I think it's right. I'm adding it, but I just added those together. Okay, then that's got it. Yes! What did I have to do? Add them all up and divide by how many there are. Yep. And I did a little bit quicker mathematics. I added them all up, but I was kind of joining some numbers together to make it quicker. But I did add up all the numbers, found out the total, divide by the total number of sample size, and we find 560 is the mean. So we see right here, the mean is 560, and then the median, now let's not look at the output, we're going to probably see the answer. But when we get the median, how would we get the median for 12 numbers? How would we get the median for 12 numbers? How would we get the median for 12 numbers? Be very careful. The median for 12 numbers, there's no middle number because there's six high numbers, 6 low numbers. Does that make sense? So with there being 6 big numbers on this side and 6 small numbers on that side, what do we have to do right here? What do we have to do? So I think I know what it is. I think I have a guess what it is. Since there's no middle number, because there's 12 numbers, so there's 6 low numbers and 6 high numbers. Great job right there, Jillian. Jillian, 50 points. Jillian, extra credit. Great job. The median's right there. It's 460, and it's the average of the 2 middle numbers because there's no exact middle number. Next question is, how many employees earn more than the mean wage? Well, we just need to look at the data. The great thing about just writing down all the data is we can see the mean is 560. So how many employees earn more than the mean wage? The mean wage is 560. There's 2 employees that earn more than the mean wage. So pretty good right there. Now this asks, what is the best measure of center, the mean or the median? So this data is very, 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 very what? This data is very, very what? So how does that data look right there? This data is very, very, very what? Skewed to the right. Here's a little monster man. There's a little monster man tail. And the mean is above the median. So it's very, very right skewed. Great job. 20 points. Everyone following along. Keep following along. Keep answering those questions. So the median is going to be better. The median best describes typical wage. The mean is not a good measure of center because it is affected by the 2 high salaries. So the mean is affected by the skew right there. So what is going to be the measure of spread that we use? So once again, we should know as soon as we use the median, what are we going to use for the spread? If we use the median for the center, then what's the measure of spread we're going to use? Great job, Roderick, right there. This takes me back to their hills. Oh, that's awesome. That's awesome. Good job, Brendan, right there. So now what are we going to use? Good review for, and we do this. We were doing Z-scores today in 474. The IQR, great. Brendan, Frankie right there, great job. I love all this positive collaboration. The IQR is what we're going to use. The IQR is the best measure of spread. I think that's got it. Boom, another 100. So the IQR is the best measure of spread. Remember what's paired together. So this kind of goes to the earlier question of which are the best measures. The median and the IQR are paired together for skewed data. So the shape of the data is the first thing we look at. Then the center would be the median if it's skewed. The IQR would be the spread if it's skewed. If the data is more symmetric, more normal looking, the mean and the standard deviation. And outliers do impact these. What's up, Cliff? And then outliers do not impact these. And this is all for univariate quantitative data, something we're working with in 474 today. We'll do a few more Stat 201 questions. I think Kate had 1 or 2. Let's look at Kate's questions next. Do a break guy. Excellent work, everybody. Kate says, how do you tell when to use the range, the standard deviation, which would be the best measure? The IQR, I think we did that one. Can you explain why median is a better measure of center for skewed and the mean is a better measure for symmetric data? So why, good question by Kate right there, and then we'll do Kylie's question. Why is the mean a better measure for symmetric data? Why is the mean, oh, right, Reed's got a great question right there. Reed, we'll do that here soon. Why is the mean a better measure for symmetric data? Like if you have data that looks like this, we use the mean. But if you have skew and outliers, what is the skew and outliers going to do to the mean? So it's almost like the mean is what we want to use. If your data is skewed, then the mean will be thrown off. Frankie right there, that's another 50 points. Frankie's right. And then also, I might still have those notes up. I want you to look at the equation for standard deviation. What do you notice? I'm going to make it appear here. What do you notice? And that's technically that. What do you notice is part of the equation for standard deviation? What do we use to calculate standard deviation? What is part of the equation to calculate standard deviation? What does that symbol stand for right there? What is that symbol right there? Y bar is the mean, so the standard deviation is also affected by outliers because this right here is affected by outliers, so this right here is calculated from it. So anything that affects the mean will also affect the standard deviation, and that's why we pair the mean and the standard deviation together. They're two, like the standard deviation is calculated from the mean to some degree, so both of these are impacted by outliers, but down here the median and the IQ are not. So does that help answer, Kate, right there? That the mean is impacted by outliers and the standard deviation is calculated from the mean, so it's impacted by outliers. So we generally want to use these shapes of data for these. So anytime you use the mean, you go with the standard deviation. If you have skewed data, the median and IQ are not impacted by outliers because these are percentile based. So when you're doing these, you're doing the 50th percentile, and this right here is the 25th through the 75th. Since they're both percentile based, it makes sense to use them together. Great job, Kate, right there. Some 50 points. Kate, keep asking those questions. We're here to answer questions and help out with the work. But no, great questions. I think there was one more 201 question, and I think we got the 320 question next after that. So the next question was from, 474, Brendan asked, so we got Brendan's after Kylie's. Kylie says, can we go over chapter 3 quiz? Kylie, which one were you wondering? Kylie wants chapter 3 quiz. Kylie, it's your call right here. I'm going to pull up chapter 3 quiz. Be like, this specific problem. Brian, can you do the problem that is like this? So Kylie asked for chapter 3 quiz. And so which question are you working on, Kylie? We'll pull up that question. We'll work it. And Stats 1 has a lot of different questions that can appear. Oh, there's only 5 questions right here. Question 3. Oh, what does the question say? So my questions are different numbers. If you can tell me the start of the question, like does it say a magazine article? Does it say just how accurate are weather forecasts? We did weather forecast yesterday. We can do it. The placebo one. We have time to chapter 2 quiz. Yeah, name another question in chapter 2. We can do that here in a little bit. You got it. An article for a school district. And we have the students in an introductory statistics course, which we didn't do this one yesterday. We didn't do the students in an introductory statistics course. So which one are you thinking? Because my numbers might be different than yours. My quiz numbers can be different. I'll see which one Kylie says, and then we'll start that up here. We'll stretch. Waking up. I could get a call from the veterinarian. So if I do take a call today, it's from the veterinarian. So I'm very sorry if I'm like, okay, 1 second, gotta take a veterinarian call. Morty's visiting the vet today. He had a little vet visit. Which one do you want to do, Kylie? If you tell me the start of it, I can find it. Like the first thing it says, like students in an introduction to statistics course, an article on a school paper, medical research conducted, just how accurate are, a magazine article examined. Let's see. An article reported on a school district. Awesome. An article reported on a school district. All right, here we go. Let's go check out article reported on a school district. Here we go. Next new topic. Next topic. Next topic. Let's do this. So this right here is an article reported on a school district, and they found from the 1,679 qualified applicants, 919 of them were accepted, 257 were waitlisted, 503 were turned away from lack of space. This is actually univariate categorical because we have what was the decision on your application. It looks like quantitative. Don't be confused. Remember, you'll get something in the mail saying you were accepted. So that's categorical right there. And so it asks first, what is the relative frequency of students who were accepted? And relative frequency is going to be a frequency out of 100%. So we would take right here 919, which is the amount that were accepted out of the total 1679. And this is going to be the relative frequency, but not as a percent yet, till we times it by 100. You bet, Abby. I think we got time, definitely. And so now that is the relative frequency right here to 1 decimal. 1 decimal. Relative frequency of waitlisted students. So if we want to get the relative frequency of waitlisted students, we do the same thing, but with waitlisted. 257 is going to be the amount that we're waitlisted over the 1679, which is going to be the total. And this gets us kind of a relative frequency here out of 1 to turn it to a percentage. We time by 100. And then we go right here and delete down to 1 decimal. Make sure to round if needed. It works as long as it doesn't do that. I love it. They actually kind of give you the answers right here. I'm not saying. The last one is the percent of students that were turned away. So the students turned away is 503 divided by 1679 times, and this one will round up. So if you notice here, 29.95 rounds up to 30%. So that's a good round on that one right there. And you got to check down here at the bottom with these numbers. That's got a good way to check this one if you get it on the quiz is to use the numbers below, practice, and make sure you realize that this is univariate categorical. We're doing one categorical question. I think a lot of times people think this is quantitative because they see numbers. But remember the response to this was, were you waitlisted? Were you accepted? Because you have to say like, what was the response for this student? You say, oh, this student was accepted. So this would be categorical right here. This is responses that are put people into categories. Does that make sense right here, Kylie? Might do one last question on this because then we'll done the whole quiz for this in multiple. So do check answer. 100%. Let's do one last one right here, and then we'll hop over to some 324.74. I think Reed or someone also question about the weather forecast. Yeah, let's do the weather forecast. Let's do it. So let's do next topic right here, the rain, no rain problem. Next topic, the rain, no rain problem. This one is the hard one. So pay attention, everyone. Let's knock this one out. You ready? The rain, no rain problem. Let's check it out. Next topic. Now, this is one of the hardest problems for people to do. We have put this on the test before in the past, not like the exact thing, but people on the test had no idea how to do it. I was like, no. So I want you to be able to read this. Let's practice reading this graphic. You ready? What does this graphic mean? This right here is what actually happened on this day. So if you were to follow this down right here, these are the days it actually rained. These are the days it actually did not rain. So I'd like you to first tell me this. How many days did it actually rain? Just using this information right here, how many days did it actually rain? She counts. Oh, you might have an issue while people are trying to figure that out. If you're having okay. Try that out, Trevor, right there. Try that. Yep, Kylie, you see it. 36, because it rained on these days and it rained on these days. But there's a difference we're going to see right here in a second. Try that out, Trevor. Thank you for messaging about that, Trevor. Try that out and see if that fixes it. Now, these are what was forecasted. And these are the days that rain was forecasted. These are the days that rain was not forecasted. So here's where it gets tough. How many days was the forecast would not rain? Tell me if that works, Trevor. Yeah. Thank you so much, Trevor. 20 points, Trevor. How many days was rain not forecasted? When you woke up and you looked at the forecast and said, it's not going to rain today. How many days was rain not forecasted? How many days was rain not forecasted? You wake up and just try to use the arrows I put on here to help out. How many days was rain not forecasted? Great job, Kylie and HT right there. How many days was rain not forecasted? I put some arrows here to help with the way the data goes. 276. Does that make sense? 276 days rain was not forecasted. So now we have to ask, I want you to describe to me this day right here. These days right here. Let's go these 6 days. I want you to describe to me these 6 days. Just tell me about your experience on those 6 days. Tell me your experience on those 6 days. Take a moment right here. I just want you to imagine this day. I want you to look at the forecast. Look at the forecast. And I want you to look at what actually happened on these days. So I want you to just explain to me what happened to you on these days. Like you woke up and you heard this. So you thought, okay. And then what happened? Be careful. Be careful. So go with the forecast. Remember, the forecast goes this way. So which of the forecasts is this? This is forecast what? ACT's got right there. So It was forecasted to what right here, Kylie? So the forecast was what? Just the forecast. Just tell me the forecast. You wake up and you hear, today is going to, what do you hear? Today is going to what? You hear this. You hear, today it will, what? This is the forecast you hear on the TV. So what is the forecast you hear? You wake up and you hear, today it will. So for all of this, right, even these you would hear this for. Not rain, exactly. But then what actually happens on that day? You're like, oh, it's not going to rain today. I looked at the forecast. It said, no rain today. You're like, oh, cool, no rain. I'll just go to campus. Yeah, just go to campus. And then what actually happened? What actually happened? So you wake up and you hear it's not going to rain. It's talking to some Family Guy right there. Some Ollie Williams. Exactly. You're welcome. No, Trevor, thank you so much. And Trevor, thank you for asking. I mean, how are you supposed to know those errors right there? Like there's a dark mode error. How are you supposed to know that? Unless you teach the class. Trevor, you know what, Trevor? I'm throwing Trevor 100 points. Trevor, 100 points for the class right here for coming in and asking that question. I appreciate that. A lot of people get stuck on that. I've got it in the playlist, but it's a common error. And since I teach the class, I kind of know some common errors. People get uncommon errors, though. So tell me what's going on with these days. These days right here, this is the last one we'll do, then we'll answer all the questions. Tell me what's going on with those days. You're welcome, Trevor. Thank you, Trevor. I'm sure everyone's very happy about those points right there. Earned lots of people a lot of points right there, asking some big questions. So tell me what's going on with those 30 days right there. Just describe to me those days, and we're going to answer all the questions that we know how to read this now. So what's going on with those 30 days? Because remember, on these days down here, we woke up and they said it's not going to rain. We're like, oh, it's not going to rain. And then it did rain on us. We're like, oh, that's great. And then right here, what happened? We woke up and the forecast said what? So we wake up and the forecast says, what's the forecast say? You can just go across. On all of these days, the forecast as I go across here would be the same. But they do differ in what actually occurs if you go across to different things. But on all these days across here, the forecast, we wake up and we see the forecast and they say it's going to... It's the last one that we answer all the questions. So we have to know how to read this. I'm always afraid I might be, oh no, like people can't read it and then they get to the test. They're like, I have no idea what this graphic means. So it was forecast rain. Kylie right there, 50 points, Kylie. Great job. You are 100% correct. It was forecasted to rain, and it actually did rain. You just have to go this way for the forecast. And Kylie, does this make a lot more sense right here? Like, if you're looking at the forecast, you have to look at this, and that's what they tell you is going to happen that day. And then when you look at what actually happened that day, like, you walk outside, and it does this. That's what actual is going to mean in this case. You have to go up and down. Like you have to go these right here. The columns are what actually happened, but the rows are what you wake up and they say, this is going to happen today. So just knowing what's going on right here and how to read this. This is one of the hardest problems I would say in this chapter. Gets a lot of people off guard, and then we put it on a test and everyone misses it. On what percent of days did it actually rain? So we need to go to actual rain right here. Yeah, awesome. Yeah, just be able to read it's key right here. So we have 36 days it actually rained. There's 365 days in the year. So 36 out of the 365. And we want this as a percentage, so we're going to times it by 100. Once again, I'm adding up these two numbers. These are the days it actually rained. That's 9.86 when we round. Can you do the problem when you have the time chapter 2 quiz? The Center for Education reported average mathematics student scores of 8th graders. Yeah, let's do that one next. Then we'll transition over to the other classes. Is this 30 an hour of office hours, or... I think we'll do one more 201 after this, and then we'll do some 324.74. On what percent of days was rain predicted? So rain predicted would be the forecast. So we have to go here to rain across here. That's 30 plus 59. So those are the days where rain was predicted. I've got highlighted back there. We divide that by 365, and then we times that by 100. 24.38. We might actually, I might come back to that, Tiffany, because it wants one decimal. Ooh, Ma Pearson. If you ever get something wrong because of decimal rounding, just tell me. I've already made one mistake this semester. Haven't made any others, but just one. What percent of days was the forecast correct? Now, this one catches people off guard because when the forecast is correct, it's because it says correct, right? It's when they predict rain, rather predict right is over here. They predict rain and it actually does rain. They predict no rain and it actually no rains. So that's 300 divided by 365. And that is the percent of time the forecast was correct, 82.2. As long as I've done all my rounding correctly. And so now do we see evidence of an association? So this is the weird one. You're welcome, Tiffany. Great job. Great job. So now we have to say, given it rained, the forecast was correct. It rained 36 days. These are the days it rained. The forecast was correct 30 out of the 36 days. So 30 days out of the 36 days, it was correct, which is 83.3. Does it look like it really matters whether it rains or does not rain on the forecast being correct? Like, what do you notice about these bars right here? Like, given it rained, the forecast is correct 83% of the time. Given it did not rain, the forecast was correct 82.1. And we could check the numbers, but this is the right graphic because this one's not. That's not the 83.3 we see. Notice how they look very similar. Like, if it rains, the forecast was correct 83% of the time. If it did not rain, the forecast was correct 82% of the time. So is there evidence of an association? No, because they're very similar. And that should do it. Did I do all my rounding? Yes, I did all my rounding. And we're going to head over and do a little more 324.74. We'll try to circle back here at the end, do some more 201. So stay tuned. Let's hop back to the main screen. I think, what time do these off hours go till? I can't remember. Let me see right here real quick. Let me go to my Google Calendar. If I get a call about Morty, I will answer. 11:30 office hours. Let's try and knock out some more. Will you scroll up to part C? Yeah, let me put that back on the screen real quick. Oh, that's the forecast correct part, right? So for the forecast correct part, I'll put it back on the screen. For the forecast correct part, make sure you add up the numbers that are connected on this diagonal because these are the days it rained and the forecast said it would rain. And these are the days it did not rain and the forecast said not rain. So we have right here, these 30 days, they got the rain forecast correct. These 270. So the way to do it is the 30, which were correct, plus the 270, which were correct. That's 300 divided by the total 365 days in a year, and then times this by 100 to get it to a percentage and then round it. Does that make sense right there, Kylie? Thank you. 20 points for asking to go back and check that out. But does that make sense right there? I think, tell me if you need more help with that, Kylie. There we go right there. I got magic screen. Let's see right here. I think the first question for 324.74 was from, this one goes out to, it's like we're a DJ host right here. Let's go here. This one goes out to, I can't find the question. Brendan, asking about 474 2B. Let's get some 474 up here. 474 2B. Let's go check this out. BAS 474. Stay tuned, Stat Tool 1. You may see some things you've done right here. Here we go, getting the homework one downloaded. So this is a new topic right here, BAS 474 2B. Let's go look at, Brendan says, let's go. New topic, BAS 474 2B. Here we go. So one of the things you can do is you can scroll through this pretty quickly by going to this and being like, oh, we got a little index right here. Boop, 2B. And let's take a look. What's 2B say? Oh, it's about missingness. Imagine that so we need to make the vector. So I need to make this vector right here. I'm just going to make the vector. Brian does similar work. Not always your question. I don't always do your question. I do similar work. So we're going to go ahead and take this vector right here. We're going to put it, how do we put things into a vector? Like, how do I put this all into a vector right here? How do I put this all into a vector? How would I vectorize something? How would I vectorize these things? How do you vectorize something? Great job right there, HTC. You got it. I'm just going to highlight all of this. I'm going to put this around here and vectorize it. We're going to store it into BAS. Once again, if you have something written like this, you can just go here and put a vector around it, and you can turn that into a vector. Now, that's a vector with the object as now it's the word, but we don't want any of that. We're just fixing this up right here. The cube root of this. Cube roots are taking something to the 1/3 power. You could confirm this if you want, but it is 1/3 power. That's how you cube root things. The number E. So E is going to be EXP raised to this power. end that right there. I think we got it. Go away. Thank you. And there we go. There's the BAS vector. So now we have that these are bogus values. So we have that 201 and negative 218 are bogus values. You don't want to store into which. You don't want to store into which. You want to use the which function. So let's say I wanted to find values that are greater than, so I'm not going to quite do this. Like, let's say I say bogus values. Once again, similar work. Like if I were to say bogus values are values that are VAS greater than, or let's say, what am I do? Let's see right here. I'll say, trying to not do the exact question. Everyone's like, do it, do it. Sure. And with this, what we can do is we can take our BAS vector and see if the values are contained in the bogus values. Now, notice where the true is. Make sure do it, do it. Peer pressure. So what do you notice? Why is this returning true right here? Why is that returning true? Still just returns true. Why is this returning true right here? It's looking at this and wait, what? Oh my gosh. Oh, those are the bogus values. Yeah, my brain's breaking. It's looking at this vector right here, and then it's asking if these values are contained in bogus values. So it looks at this right here, and it says, is this contained? There's the answer. It looks at this and says, is this contained over here? So it doesn't matter what the positions are necessarily, which what it's saying is, it's saying that, so we're changing this over here just to other things. It'll still only return one true because why? So why is it only returning one true right here? Let's show what bogus vectors is. Let's show what BAS is. Let's show what this evaluates to. Why is it only returning one true right here? Why is it only returning one true? And it is correct that position 1 is 201, but it's that for 201, could you explain why a 5 North summary is? Oh, yes. Here, I'll put it in the chat real quick. Why is it only returning the min? I put it in the chat right there, Jillian, for you. Then we can talk about that more next, you bet. Because it only shows the values, it only returns true if this value is contained over here. So it looks at this and says, is this contained over here? Does that make sense? It says, is this value in the BAS vector contained in the bogus values vector? So now that we have this right here, let's go and turn this into a which is going to take it and tell us the position of the thing in the BAS vector that is a bogus value. So now that we have the position of it, imagine that our value is trying to replace the two values what they are. Missing this, you can write this two lines. So now we need to go here to the BAS vector, and this is it just seems crazy. Take a look at this. What will this return right here? Think about what this code is right here. I want you to think about this. All this code is this. This code right here, you see all this? That's all this is. So what will this code return? Hint, look at this. What will this code return? Because everything I've written right here goes and tells me what elements of the BAS vector are contained in bogus values. It returns the positions of those. And so this is going to only return what? Just remember, this whole thing right here, this right here is this. So the square brackets return positions. The parentheses are used primarily for functions. So we're returning position 1 in BAS vector. And then curly brackets are for like creating functions. Like when we create functions, when we do functions, you use the curly brackets. And those kind of open up like executing functions. Like I could show more on that. If we have time, we can do discussion over chapter 3. Yeah, I think so. We might have to do them. Might have to do some of these during afternoon office hours, but definitely today. Definitely today. And so what is this going to return right here? Thank you so much, everyone, being here. Really good office hours today. What is this going to return right here? Thoughts? Remember, this is just 1 right here. So all this is up here is 1. And you can see what the BAS vector is. So what's that going to return? It's gonna return the bogus values, and it's going to return the things in the positions of the bogus values. And when we run this code, it's just going to return 201. So you know what we can do? We can write into it. And the reason we do the code this way is because this will, if we run it again, it's not going to overwrite anything because there are no more bogus values. If you try to find if there's bogus values now, you'll just get falses because there are no more bogus values because we overwrote them. So it's a really safe way of doing it. This will return in logical 0, integer 0, which means an integer vector of length 0. And then there's nothing to overwrite when we do this. This might return numeric 0. Gotta get better at my empty things. But that's returning nothing right there. It's returning a numeric vector of length 0. Is this making sense right here? Is this working pretty well for this one? How are you doing, Brendan? Does this make sense? I've kind of written it out, not completely, but pretty close. It's very, very similar. Very, very similar. And let's see. Was there, Abby wants 8C for 474. Let's do that. And so let's do a 474 8C. Is there a way to double check that you're on the right track? When you view your vector again, so to see if you're on the right track, when you print your vector at the end, what should you see? Which mine is not the right answer, but when you complete your vector, what should you see? 4G, and there's another one. Abby, can you put both of them in the chat? I'll try to do both. And then might try to do another 2-1 after this. What should you see if you complete this properly, if you print the vector? Because does it say print the vector afterwards? Print the contents to the screen when you're done. Yeah, it does say it. What should you see when you print the contents? Because I did what I wanted to do, which is not quite what you want to do. What should you see when you do this and you replace the values with NAs? You should see that the vector has NA for the values of what we have right there. So let's take a look. We'll do another question right here. We'll do Abby had 4G. We'll do 4G next and put the other one in the chat, Abby, too. Oh, you over here? Let's do some 4G. After I was going to take a look at my email sent. Yep. Definitely, I'll try to take a quick look at the email. You got it. I need to remove this pick up groceries. I already picked up the groceries. Delete pick up groceries. I already picked them up. They're going to be mad at us. They're saying you never picked up your groceries. Let's do some next topic, 474, 4G, and then we'll do the other one here. Next topic, 474, 4G. Let's check it out. Once again, we got our quick thing right here, our index to go down to 4G. So I like to do the question along with it. What fraction of values in the tomato meter are NA? So if you want to know if something is NA, that's the function. 320. Oh, we'll do some 320 after this too because we're not doing 320 today. So I'm going to go right here and add a chunk. I like to do the chunks right next to where I'm working. I also like to name my chunks. That way, if I ever want to go back to them, I could just be like, you know, that 4G chunk, I miss it. Hey, what's up, 4G? Let's call it Q4G. And so that's just a name for a chunk right there. Be very careful. Make sure you don't break things. If you're looking to see if things are NA, I think, does this data set have any NAs in it? I'm going to see something. No NAs. I'm using a different data set. Once again, I do similar. Oh my gosh. I do similar questions, not quite the same. Okay, there we go. So similar but not quite the same. Great job right there, Brendan. Excellent work. So what fraction of the tomato meters are NAs? So what are NAs? Like when you see an NA here, what does that mean? You got to know this pretty quickly. You got to be like, I know what NAs are. I know what it means. Here's what an NA looks like in Jump. If you're in 201, you're like, what does an NA look like? NAs look something like this right here. That's what an NA looks like. It means the data is what for that cell. So if you see an NA right there, which we see, this is how Jump would represent them. And that's not a dot, missing values exactly. So it's good to know what a missing value looks like. It's just that there's nothing there. Nothing at all. Nothing at all. And so watch this. If I go right here, and actually we're kind of doing it. We've kind of answered this question. what is this doing right here for me? This first one is telling me how many NAs are in the whole data frame. The second one is telling me what fraction of the data frame is NA. You can do this for vectors also. With vectors, like if I want to look at, is it married or drinking? I think the drinking questions have it. Number of drinks at a party, yes. If we go right here, in this vector, there were 70 people who did not answer the question, how many drinks do you have at a party? Maybe they just don't drink or they didn't want to answer it. Who knows why, but we don't have their information. The 70 people, if you think about it, 70 people, and the survey has 579 in it, well, that would be 12.08%. And this is what we've been doing for 201 a little bit with frequencies. And if you look at the 201 things we just did, it's very similar to where we could say 12.08% of the people or 12.09% of the people did not answer the question, how many drinks would you have at a party? And we're using the is.na, and we're putting it inside of mean to get the fraction. We can times it by 100 if we want. Or we can do sum to find out how many. And why is that? How does R see ones and zeros? How does R see trues and falses? Brian's giving away answers today, 20 points. How does R see trues and falses? Like, what's going on with trues and falses and the way R sees them in its brain? How does R see trues and falses? Like if I were to go here and to go to the sum of true, 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 false, 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 how does R see trues and falses? Well, this has 4 trues, so the sum of it is 4. Because R sees trues and falses is ones and zeros. Abby sees it right there. Great job, Abby. And then the mean would tell me the percent of the trues, which is going to be 66%, because 2/3 of it, or 4/6 of it, because there's 6 observations and 4 trues. So this tells me the percent of the trues, and you can do this for any logical vector. Like this is just a logical, which tells you if something is NA, and then you can find out the percent of things that are NA or the sum of the NAs. Great job there, right there, Abby, with some 4G, making it way more complicated. When you see her like, oh, I get it. It's just like, I get it. I can't believe it. Let's go check out the other one right here. Let's do it. So this is the next topic right here, 8C. 8C. Let's go check out some 8C, new topic. Next topic, 8C. Okay, here we are with 8C. And 8C says, oh my gosh. Might not do the whole thing right here. This is the spot for 8C. This is about validation right here. The price column is considered to capture the price listed of the buy box. When I try 2C to get the mean, basically keeps saying NA. Oh, make sure you do NA.remove equals true. Make sure you do the NA.remove equals true. So you need to make sure you have the additional argument, comma, NA.remove equals true. Great job, Brendan. 20 points. Actual work. Represents the highest and lowest prices, number of sellers, which are sellers. However, the software might bug out and fail to record it. Couldn't parse the page. All this good stuff right here. Write a command that uses the length and the width to print out the total number of NAs. I think we're good right there. Define the price fixed to be the vector. The values contained in buy box. Let's get rid of some of the problems values. Guess that just reversal values. Let's go right there. And there are column constraints in this data set. The value in low should be less than or equal to the value in high. And we want to find out using the mean to determine the percent of rows that violate this. So use the mean of a logical condition to determine the fraction of rows which violate each constraint. Do this for each bullet point separately. We aren't looking for the fraction that violate all 3 constraints. Since there are many missing values, you'll have to add a certain argument to mean. And there it is right there. The NA.remove equals true. And there we go. So that you get a number out instead of the NA right there. So with this right here, let's just do one of these conditions. We have the buy box. So we need to look at that buy box data set. And the buy box data set is, where is it? Where'd it go? Let me delete out the data frames. And here we go. And we're using the buy. Okay. And then we're doing low. Okay. So let's go here to buy $low. And we want to figure out the value in low should be less than or equal to the value in high. So if we want to see if the value in low is less than or equal to the value in high, we can go right here. And this gives us what's and what's is. Who knows? I need chat to tell me. This gives us what's and what's is. We'll do 320 after this. What is this going to give us right here? If I see if the value in low is less than or equal to the value in high, what does this give us? So think about what this code will give us. I'm not like asking the whole thing. Like just think of like what type of thing it'll give us as output. When I run the vector low is less than or equal to the vector high, what will it do? Like what will the output be? Trues and falses, Abby, great job right there, 20 points. You are correct, Abby. Trues and falses. So this is going to give us trues and falses right here. You are very correct. And so now we want to find out the fraction of rows that violate. But here's the thing, there's missing values. So if we run this, we will get NA. So we have to add in here NA.remove equals true. And there's, ooh, wait, what? Oh, wait. These are the ones that are equal to. So if we want that they violate the condition, because we're trying to find the ones that violate the conditions. So here's the thing. Here's what's really cool. This means everything conforms to the condition. Watch that. Oops, what did I do? Oh, my brain not working today. Want to go right here to the whole condition. Want to go around it, exclamation, and this flips everything. So if you have falses, if you put an exclamation before them, you get true. So if you have trues and you put an exclamation before it, you get false. It's basically not true, not false. So I basically said something does not follow this condition. Here's the condition, and then I did not the condition. So we want things to be less than or equal to high, and then I said, what are the things that do not meet this? Does that make sense, Abby and everybody? Like, I just wrote the first, basically I just did the first one right here. But this says, here's my condition. Things in the by are less than or equal to high. And then I want something that does not meet this condition. So I kind of set this apart, let it evaluate. Sometimes, like how many conditions are we checking? We're checking these right here. There's two more. So I just did one out of the three. The value in price should be at least low and at most high. Violated when price is less than low or price is greater than or equal to high. Sanji check close to this right here. And we'll do one more right here. The value in price should be at least low. So if we go here to buy, we go here to price, it should be greater than or equal to price low. So it should be greater than or equal to that. The price is, and at most price high. So it has to be end by $ price is less than or equal to by $ high. So it's somewhere contained between these two numbers. And these are the things. And then I want not these things. And that's got it right there. And then we want to wrap this in a mean. And then we want to throw the extra condition. NA.remove equals true. And there we go right there. That's got it. Let's take a look at it again real quick right here. I'm going to put this to a new line right here. It's a little iffy right there. I don't know if I put that on a new line. So it got a little bit long right there. Oh, you know what? Let's put this to a new line right here. And you can see this. There we go right there. So this is the condition right here that something has a price that is at least greater than or equal to low. And the price is at least less than or equal to high. And then we want things that do not meet these conditions. That's the easiest way to put like a not around something. Is like, here's my condition. It needs to be da-da-da-da-da, da-da-da-da-da. And then I want the things that do not meet these conditions. Once again, I'm just wrapping the full condition I wrote. And if thing meets it, then I can tell the things that do not meet it. Rather, we're checking a condition and we're going to be turning, does it meet it true? Yeah. And then we would get right here. If it does not meet the condition, we would flip that into a false, into a true. Does that make sense right here, how I'm flipping things? I think this one is much easier when you flip them. You could write it the way that it violates the conditions, but it gets a little bit iffy because then you have to write something that is less than, we got a little bit of time. I want to make sure I do this. You'd have to write it's less than low or greater than high, and I think that would do that. So you could do that right there. And the other way to write this without using the not would be the price is less than low or the price, so we want an or now, or the price is greater than high. Try writing it other ways, and we do get the same answer. Yeah, so it's tough. You have to think about, okay, wait, we want it to be greater than or equal to low and less than or equal to high. So it has to be contained in this boundary. If you write the other way, it's say, or like another way to write this would be, it has to be less than low to violate, or it has to be greater than high. And we want the things that do not conform to meeting the condition. That's why I put the not right here. Like this is meeting the condition. This is not meeting the condition. This is just flat out writing not meeting the condition. Like it is less than low, or it is higher than high. Can you go with the bivariate visual for the star test one? For such, we might not have enough. We can probably do that later today, Olivia. Great question, Olivia. Thank you so much. We're gonna do a 320 right now. We do have a really good video on that. Let me get you that, Olivia, right here. 2 seconds. Let me put that in the chat, Olivia, and then we're gonna do 320. Let me go grab that video. Visualization. Wait, histograms. Oh, man. Trying to find, wait, let me go to the... Thank you so much, everyone who's here. Trying to get this... I'm going to drop this one video in the chat, and we'll do 320. We did it last week. We could do it later today. 26th. Here we go. Here, found it. Number 2. And so we got it right here. Let me copy this. So, oh, no worries. No worries. We're almost done with it. No, Olivia, thank you so much. And I just dropped the video in the chat, Olivia, right there for you, where we go through each step by step for visualization 2. And I will be back later today doing more office hours. But Olivia, 100 points right there. Jump in, ask those questions. We're going to do the 320 question right here. But no, that's what I want people to do. I want people to just ask the question, because if you wait to ask questions, then there's a lot of questions usually in line. So I try to do as many as we can. No, you're welcome, Olivia, and thank you for asking. I always want people to be like, hey, Brian, can you do this one? Because I feel like someone waits till like there's a down, like, oh, we're, which you said you just jumped in. So no, that's exactly. Then you did it perfectly. You jump in, you just say, hey, Brian, can you work this question? And then we work as many as we can. The next question was a 321. You're welcome, Tiffany. Great job today. I tried, but I got different numbers. Brendan, maybe send me on Discord. We'll take a look. Let's see. The 320 question was. Oh, yeah. I thought I broke my microphone at the start of the stream today. I was like, oh no. Can you do 320 assignment 1, number 5? Number 5. Let's go over here. New topic. 320, number 5, new topic. 320, number 5, let's take a look right here. We got some integrity issues with the data right here. So when it comes to this question, basically what we're doing is we're taking the vector, which is going to be the Greek life vector, and we're storing it. I think it's currently called fraternity sorority. So we have here the alumni data frame, and the alumni data frame, we're going to take inside of it the fraternity sorority vector, which is just Greek life that people have, different Greek life organizations, and we're going to store it into the vector Greek life. Are we appending that to the data frame? Add a column. Now, to add a column to a data frame, you can call the data frame and then put a $ to make a new variable. You'll see variable names right there. If you write to one that does not exist, then you can create it. Now watch how at the bottom of this data frame right here, you can see we've got the data frame, and at the very bottom, it's log lifetime gift to UT. And now at the very bottom, because I appended to it, we now have a new variable at the very bottom. We've added onto this a new vector. So with the new vector we've added on, we can check how many levels does Greek have. To see how many levels something has, we can go and look at the levels vector. Levels are for what kind of variable? 20 points. When we're talking about levels, we're talking about what kind of variable right here. Levels are for what kind of variables? Like, what does a level mean? Like, freshmen, sophomore, juniors, seniors are levels of someone's class. We could go here and we could say state has different levels, like North Carolina, Tennessee, New York, all those different things right there. State has different levels. And look at these different levels right here. Here's the different levels. These are like things for what kind of variables. What are levels again? Levels are when a variable is a what? You can see it over there. So levels are for what kind of variables? We can see there's 65 levels, but let's make it even better. Let's go here to the length of this. And there are 65. There's 65 levels. You can see it right there. What are levels for? What's the point of a level? Not just in Super Mario or Mega Man. There's a Mega Man. He goes all green screen if I turn him on. Look at that. He's green screen. You can see through Mega Man. So what are levels used for? What is the point of a level? Levels are for what kind of variables? 20 points on the line right here. Levels are for what kind of variables? Think about like Greek life has different levels, so it's a what kind of variable? Stat 201 question right here. Greek life has different levels, so Greek life is a what kind of variable? And these are just the different answers to the questions. Always trying to connect our knowledge to what we learned in Stat 201. No one knows. Ah! Greek life is a categorical variable, and the levels are basically different answers to the questions. So how many people went Greek in the data? This goes back to a lot of, I might skip this one here. Categorical, Reed, thank you so much. Reed, 100 points. Thank you so much. It's categorical right there. So categorical with different sort of responses right there. What sort of integrity issues do you see with this column? I'm going to skip that 5C right there. Not do all of it. So when you look at this column right here, if you were to look at the levels, which you don't want to print this out, I'm not going to say the answer. I'm not going to write the answer, but I just want you to start looking at this. These are the responses people give. Yeah, exactly. Email me a question. I'll try to do it during office hours. Discord me a question. I'll try to do it. Definitely, yeah, the sooner the better. And usually, yeah, I'll try to do it, Kylie, you bet. Does anyone notice anything about these like that are odd? Like if I were to go here and if I were to just report one of these to the screen, does that look weird? If you say, what Greek life are you? And I say, oh, I'm in UTK Kappa Sigma, UTK Kappa Sigma, UTK Kappa Sigma, UTK Kappa Sigma. And you're like, what? This is an individual who reported, if we go here to alumni, and we'd have to find them. So let's, alumni, let's go to, oh my gosh, my brain's not working today. Alumni, $ Greek. And then let's go equals this, which, that's the person. And if I go here, do not do this. There we go. And I report this person. Let's go here and go to DF2. I'm just going to view it. And here's this individual. This individual for Greek life, which we need to go all the way over here to the last column. In Greek life, they reported the following. This is the person's answer to the question. Is UTK Kappa Sigma, UTK Kappa Sigma, UTK Kappa Sigma? I know, right? The which function that returned to me which individual this is. If you look at the function I wrote right here, I went and found which individual this is who had the report of being UTK Kappa Sigma, UTK Kappa Sigma, UTK Kappa Sigma. Like you literally asked someone, what fraternity or sorority are you? And they said UTK Kappa Sigma, UTK Kappa Sigma, UTK Kappa Sigma, UTK Kappa Sigma. And you're like, what? What? Doesn't make sense. Because this variable Greek life right here has all these different responses. It's just the different responses we have right here to the question of what Greek life are you in? And we can go look at those responses over here. We could sort it and take a look. Oh my gosh. And you can see the different responses right here. There's UTK Zeta Alpha. And you're just looking at the different responses to what people said when you asked them, what Greek life are you in? And someone said UTK Kappa Sigma like 4 times. And you're like, that's interesting. You're like, that's a weird response. And the data set's going all crazy as I try to load it. Oh, we're down to the non-Greek life now. There we go, UTK Kappa Sigma. And that might not be our UTK Kappa Sigma person 50 times. We haven't found them yet. But you can see all the different responses right here by which people did it. Lambda Chi Alpha maybe or something like that. But this is what it has right here. I think that's got it. So we basically did a good of this. So it was just maybe good question right there, Avatar. Maybe an input error. Don't know. We'd have to go to the original data set. It's a really good question. Like we go to them and say, what are you doing? What is this? And that's not the only weirdness we see. Really good answer right there. That's some 50 points. Great answers. We saw other weirdness with it too. And you can experience that weirdness and see it for yourself by just taking a look at the levels vector. Be very careful reporting a whole bunch to the screen. But you can see other people reported like Phi Gamma Delta, Phi Gamma Delta, Phi Gamma Delta. Some people reported different fraternity sorority combinations. Alpha Theta Pi. No, maybe they didn't. I thought there was a person who reported a different one. But you see a lot of repeat. Oh, there we go. Phi Gamma Delta, Phi Beta, Sigma. So is it a input error? Is it like a recording error? I don't know. But this is just a choice people made. Like if I were to look at class level of individuals, like if I go to levels, which do I have this up? I don't have survey 10 up. Don't be doing this. This is not needed. Oh, we don't have class level in this one, do we? If I were to go to the class level of individuals and look at levels of survey 9, $ class, what you'll notice is the classes we have are freshman, sophomore, junior, senior. That doesn't mean the first person reported freshman. These are just the options for the answers, which is what we're looking at here. Does that make more sense to everybody? Like, these are the options we have for answers for what is your class level. People responded with freshman, sophomore, junior, senior. These are the options we have for what fraternity sorority are you in. People responded with these answers. This is not how many people responded. It's just the type of answers. We also see another issue here with a blank, which is probably not how we want things written, but that probably means someone did not join Greek Life and it's just a blank string right there. So that's a bit of a recording error, I'd say myself too. And this one's properly recorded. If you want to see what people actually responded and to what rate, you could go right here and go table, and you could get a table of the responses right there. You're welcome. Anytime, Roderick. I think that's got it. I'm going to grab some lunch real quick. But this is dealing with kind of factors and validating data. Hey, what's up, Finch? Good to see you here. Going well. Went back here to the main screen. Woo! Time to go main screen. Great job, everybody. Really good office hours. We will be back later today with more office hours. I'm going to teach some 320, then office hours, then 475. And just remember, keep asking those questions. If you're ever stuck, just let me know. We've got a lot of people helping out on Discord. 201 is one of the most quiet classes. No, it's all right. It's all right. But post questions you have. Remember, other people are probably wondering about it too. Even if you're like, hey, Brian, have you worked this question in office hours? You know what? Maybe I didn't work it this semester, but I bet you I can find you a video where I worked it a different semester. And I'm always happy to work questions anytime you want. But maybe, like I can find you a video right away if I'm not currently online to work questions. So please be like, hey, Brian, I'm stuck on this question. I have no idea what to do. And post it in the public chat. I promise you, if someone else is stuck also. And if you see a question that you posted or someone posted that helped you out, hit a like on that, put an emoji on it to show some support. Because the more people we have using Discord, just the more help people are getting. And that's the goal, to learn together, to work together here on Stat 201. Puppet Shark, say bye to them. He said bye. Bye for now, everyone. Bye.